Unit 5, 5.1 is on the Polygon angle sum theorem. This is the first section in a chapter that's going to be primarily dedicated to four-sided shapes. But before we get to the four-sided shapes, what we're going to do is we're going to start you off with dealing with all polygons. And one thing I need to let you know about polygons is that our textbook only uses convex polygons, not concave. Convex polygons are like these two examples right here. They are filled in. There is nothing that is indented like these two. If you want to know the actual definition of convex and concave, it has everything to do with extending the line and making something called the exterior angle. If I were to extend this line, this is the interior angle, this is the exterior angle. Convex polygons only have exterior angles or exterior lines that do not intersect with itself. Whereas convex, if you were to try to make that convex or concave, they actually have exterior lines that would be inside the object. That's the technical definition. But just so you know, if you ever think I could draw a different shape this way, we're not going to use anything like that. We're only going to use shapes that look like this, just in all of our examples. In this book, and every formula that I give you, when we say the formula or the letter N, it's going to represent the number of sides. These polygons are going to be named off of their number of sides, and so they will give you a word like hexagon and say find the sum of the interior angles. And so if they say hexagon, we're expecting you to know that a hexagon has 6 sides and an octagon has 8 sides, and these are the names of the shapes that you need to know. If you do not know them, I'm having you write them down just in case you get asked something like that. But anything past 10 is usually written as a number with a hyphen and the word G-O-N, gone. So, for example, a 12-gon is something that has 12 sides, and 20-gon is something that has 20 sides, and so on. Which brings us to the interior and exterior angles of a polygon. So it doesn't matter how many sides something has, but if you think of like these are the interior angles, exterior angles are the ones that just extend and are outside the object. And that's important because when I look at your 4 formulas that you have, knowing interior and exterior, inside, outside, inside, outside, and that they're always supplementary, they always add to 180, that's going to help you solve a lot of your problems. And basically, this first section is on 4 different formulas and how they're created. And so instead of me having you memorize all 4, I'd love to show you where they come from. If you understand where they come from, it's so much easier to know how to get to the formula if you know how it was created. The sum of the interior angles is n minus 2 times 180. If you think about a triangle, this angle plus this angle plus this angle adds up to a total of 180 degrees, right? It has 3 sides. 3 minus 2 times 180 is 180. This formula works for something you already know. If you think about a 4-sided shape, if I were to try to split this right down the middle, like right there, then I would know that these 3 angles add to 180 and these 3 angles add to 180. And so that together they would add up to 360 degrees. If it has 4 sides, I can make 2 triangles. 4 minus 2 is 2 times 180. That's why this formula works. If you have a 5-sided shape, you could draw 1, 2, 3 triangles with it, and 3 times 180 is 540 degrees. So I'm hoping you can see that this formula is basically taking away 2 of the sides and multiplying it by 180 because it's all based off of the number of triangles you could fit using one vertex of the polygon in a convex polygon. Now, if we were to talk about the exterior angles, if I were to take this exterior angle, let's do this one instead. And this exterior angle, and I were to add all those up, it doesn't matter how many sides you have, those all add up to 360 degrees. Why 360? Think about how this would look if you were to shrink out of this thing. What if you were to make that smaller and smaller and smaller? Eventually you would get something that looks like this. If I went from here to here to here, look at how that looks. This plus this plus this makes one full rotation, or 360 degrees. That would be the same for a 4-sided shape or a 5-sided shape. The sum of the exterior angles is 360 degrees. And this works for any polygon that's convex. The word regular means that every single angle and every single side are congruent to each other. I also think of regular polygons as the ones that are perfect, the ones like a Palomino pencil. Every side is exactly the same side length. Every angle is exactly the correct angle. It's beautiful. Anyhow, for regular polygons, if I want to know what one individual interior angle is, I take that sum formula, bless you, and divide by however many sides you have. So if I think about a hexagon, if I want to know what one of those angles is, I just take the formula for the sum of the hexagon and divide by 6 sides to know what an individual interior angle is. For exterior angles, since the sum is 360, you divide by however many sides you have. And of all the formulas, that one is usually a lot easier to work with than that one, just so you know. Okay, so let's do some examples. I had this one, but I'm not going to use that after all. Let's go to number 6. This is in your textbook. If you want to do this in your textbook, you are welcome to pull that out and do this with me. My first question to see if you understand a word I just defined earlier. Is this a regular polygon? It is not. Which should automatically mean we're not going to use any of these two formulas at all for this shape. This says find y. We got to figure out how many degrees it is. So the first thing is I got to go, what do all of these add up to be? And I can use one of these formulas to figure that out. The sum of the interior angles. The sum, adding up all the inside angles, will add up to a total of whatever this value is. So if I look at number 6, number 6 has how many sides? Let's start counting. 1, 2, 3, 4, 5, 6, 7. This is a heptagon. 7 sides. Let's pull that back open again. It has 7 sides. How many sides? I have 7 minus 2 times 180 degrees. So I automatically know that 5 times 180 degrees is the sum of all of those together. Let me plug that into my calculator because I don't know what 5 times 180 is. It's 900 degrees. That's what all of these need to add up to be. So then what I can do is I can create an equation using that first formula. I can say something like y plus 125 plus 135 plus 130 plus 129 plus 116 plus 120. All that should add up to 900 degrees. Because these numbers are so big, I am going to recommend that you use a calculator throughout this first section. It will save you time for all that computation. I've added all these up together and I'm getting 755 degrees for that part. These 6 angles add to 755. Plus y should add up to 900. So all I have to do now is subtract 755 from 900. And what I'm getting is that y is equal to 145 degrees. Is that what you got? Good. So if I asked you to find the sum of an interior angles, that's how you do it. But this is how you use it to figure out a missing side. Next example, number 18. The sum of the interior angle measures of a polygon with n sides is given. Find n. So I gave you 4 formulas, and they're giving us the sum of the interior angles of a polygon with a number of sides that we don't know. But we know that the sum of the angles adds up to 2,880 degrees. So what I'm thinking is I can take that number and I can set that equal to one of the formulas. I don't know how many sides it has, but I know if I subtract 2 times 180, that will give me the sum of the interior angles. I'm going to use that first formula. Now some of you are going to want to distribute here, and you can distribute if you want to. But what instead, since this 180 is multiplying the group, if I divide, I think it makes everything smaller and easier to work with. I personally will divide by 180 to both sides because 180 goes into 180 one time. 1 times n minus 2 is just n minus 2. That's a little bit, makes everything a little bit smaller first. But if you want to distribute, go for it. You can solve this by distributive property. It doesn't matter. 2880 divided by 180 is 16. And we can do the last step on in our heads. Add 2, add 2. The number of sides that has a sum of 2,880 is 18 sides. It's an 18 gone. Does that make sense? Any questions? I have 2 more examples, 24 and 25. Here's 24. 24 says, find the value of each variable. This is an exterior angle. 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 There's one exterior angle at every vertex. The sum of the exterior angles, doesn't matter how many sides it is, one at each vertex means that all of these should add up to what number? Say it out loud. Wonderful. And so I can say that 2x plus 3x plus 4x plus another x should equal 360 degrees. I'm thinking that's 10x equals 360. 4, 5, 6, 7, 8, 9, 10. 10x, divide by 10, divide by 10. X has to be 36. Last example. The measure of an exterior angle of a regular polygon is given. Find the measure of an interior angle. Then find the number of sides. So if you're thinking about this as being 72, there's some object out there like this, and we know that an exterior angle is 72 degrees. Find the measure of an interior angle. And it's regular, so they're all the same. Visually, you should be thinking it's something like this. That's the exterior. What's the interior? It needs to add a 180. Some of you can probably do that in your head. You don't even need a calculator. X is what? Say it out loud if you know it. Ooh, a lot of you know it. 108. That's the interior angle. Each interior angle for that matter. There's a second question that says find the number of sides. Now, I personally would like to use the easiest formula that has the number of sides in it. When I go over here, I could solve this with the interior angle formula or the individual exterior because it's a regular polygon. Which formula is easier? The bottom one. I'm going to use the bottom one if I have a choice. So I know that an individual exterior angle is equal to 360 divided by n. If I know that the exterior angle is 72 degrees, then I can easily set this up just like that to solve for it. But if I do, make sure you know that your variable is in the denominator. You can never solve for anything when the variable is in the denominator. You always need your variable in the numerator if you're solving something like this. So I'm going to show you a couple different ways to do it. There's medium ways, long ways, and other ways, but the fastest way that I've learned to do this is, well, do I want to do it that way? Okay. Is I'm going to use the reciprocals. Think of this as a proportion. If this is 360 divided by n equals 72 over 1, then that's the same thing as n divided by 360 equals 1 over 72. I'm just going to flip. If I flip the right and I flip the left, it's going to be the same. Think of it as 1/2 is equal to 2/4, and you flip it, and you have 2 over 1 is the same as 4 over 2. It works. You can flip both ratios, and it will still be equivalent. And what this does is it brings your variable to the numerator, and now you can solve. Instead of dividing by 360, times by 360 in the numerator. 360 goes into 360 one time. All I have to do is 360 divided by 72. 360 divided by 72 on 360 divided by 72. Goes in 5 times. If you don't like that method, there's other ways to do it. You could also, I've seen people do this, divided by n, times by n, times by n, 360 n, 360 equals 72n, divide by 72, divide by 72. You can do it in 2 steps if you want to, and you'll still get the same answer. I've also seen some people just switch the n and the 72. But what you don't want to do is just divide by 360, because that's what 1 divided by n is, not what n over 1 is. Keep that in mind. That is the end of our notes.